Hey, what's up guys? I'm going to show you guys how to build a computer. So first I'm going to talk about the parts, and then I'm going to show you guys the whole install process, putting them inside the case, and once everything's connected, I'm going to show you guys how to install Windows. So we're going to go from parts to basically a full running Windows computer. Now all the parts that I've used, I'll put links in the description below, so be sure to check those out. And while you're down there, smash that subscribe button. If you guys have any questions or comments, leave it in the comment sections below. I do try my best to answer them. Alright, so starting off with the case. Now the case, I look for two things. Number one is airflow, and number two is design. Now airflow to me is a little more important than design, but design is also important just because I like the way it looks. Now I got the Corsair iCUE 4000 XRGB. I like this case because it's not too big and it looks really nice and it has good airflow. So we have 3 fans here. I'm not sure if the camera's showing that, but basically you get airflow from the sides right here, and when you look on the top, I mean this is glass, so you're not going to get any airflow here, but when you look on the top you have one of these magnet things which is really useful for dust collection. But you can see this part's pretty much all open, and I'm going to put some fans up here as well so it could blow air out. And when you're putting fans, you kind of want to put them in a direction where they kind of direct airflow in a way. And you can see from the back, you know, there's a lot of airflow. There's a place for a fan up here, but basically it's pretty good airflow. There's a variant of this that actually has even more airflow, that this is kind of a mesh. But I like the way this one looks. And this one is cool because I kind of wanted to have 2 USB-A's up here, but I think there's a newer version of this that does have that, but it's slightly bigger. I kind of like the size of this, but I have a USB-A and a USB-C, and then I have my microphone, and I believe headphones can go there as well. So power and reset. So that's pretty much it for the case. Alright, so before I talk about the parts and why I picked them, when you're building a computer, you have to think about your use case. What are you going to use the computer for? So in my case, I do a ton of video editing for 4K footage for YouTube. So I need something with a lot of processing power, which is why I picked these parts. It just so happens that this is also going to be a really good gaming machine, so if I want to game on this thing, it should be fine. So starting off, AMD Ryzen CPU, I got the Ryzen 7 5800X. Now, what is a CPU used for? CPU stands for Central Processing Unit, and it is the part in the computer that when you issue a command, so if you're moving your mouse, if you're opening up a game, if you're opening up an application, if you're copying files somewhere, this is the guy that basically does all the instructions for that. It basically tells everything what to do. And you know, it talks to the RAM, it talks to the SSDs, it talks to the video card. It basically talks to everyone and does your task. So for video editing and stuff, and for just really anything, it's important to have a good processor. For the CPU, you need a heatsink. I actually bought this heatsink many years ago, but this is an AM4 socket, which I will discuss when I get to the motherboard and stuff. But this is an AM4 socket, so you have to kind of get a heatsink designed for that. Now, when I bought this heatsink, AM4 wasn't out because I bought this a few years ago. So I'm going to try it out, but I think it should be compatible with that because it's really just a heatsink that goes on top and keeps your CPU cool. Now, heatsink is very important to get a good one. You could get one of those AIOs and stuff, or you could get just one of these regular fan ones. Alright, moving on to the motherboard. Now, the motherboard, unlike the heatsink, has to say AM4. Now if it doesn't say AM4 socket, it will not work with this. So make sure it says that. It's something it communicates with. Unlike the heatsink, that's really just metal keeping this cool, this one actually has to say AM4. Now what is the motherboard? What's it used for? Well, a motherboard, as its name implies, is the board that everything connects to and is the interface that everyone talks to each other. So if the CPU talks to the RAM, goes to the motherboard. If the CPU talks to the SSDs, goes to the motherboard. If it talks to the GPU, goes to the motherboard. If the GPU talks to the RAM, goes to the motherboard. Everything is pretty much through the motherboard. So it's important to get a good motherboard. Now, I got the ASUS. I really like this motherboard. I've had ASUS for a long time. I've had ASUS boards for a very long time, and they've always been really good, so that's why I stuck with them. I've also had Gigabyte and MSI. Those have been good as well, but I've had ASUS for a very long time and have been very happy with it. So there are two main chipsets for the new AMD chips, which are the X570 and the B550. Think of the B550 as a slightly lower end than X570, kind of. And a B550 is still really good. And, you know, if you're asking yourself, do I need the X570? Can I get a B550? Well, the X570, the main differences that I saw were really just that the X570 has more PCI Express 4.0 slots. So basically, because I have PCI Express 4.0 SSD NVMe's and the video card, that's why I actually need them to be PCI Express. The B550 also has a lot of slots too, but doesn't necessarily mean that they're PCI Express 4.0. And the cool thing about this motherboard is it can handle a ton of RAM, up to 128 gigs. Not that I need it, but it has USB, a whole bunch of fast USB ports. It has the 2.5 gigabit LAN, and it has Wi-Fi 6. So it has a whole bunch of cool stuff that you get with this. Okay, so moving on, we go to the video card. Now this is my second choice for video cards, even though this video card is phenomenal and is actually better than my first choice. But I was trying to get the RTX 3080, but right now, at the time of this recording at least, video cards are very hard to come by, just like some of the CPUs. So I actually was able to get this one, so I was super happy that I did. But if I had a choice where I lived in a world where NVIDIA video cards were not sold out, I would get the RTX 3080 because I think it's better bang for your buck. But this is a very, very good video card. Now, what is a video card used for? Why is it important? Well, if you're gaming, very important to have a very good video card. You know, if you want to game at high resolution settings, you need a really good video card. If you're doing video editing, you're doing rendering, you need a good video card. Anything you do that's graphical uses the video card. So this, you know, if you're watching 4K videos and stuff, that also uses your video card. This pretty much powers up your monitors and tells your monitors exactly what to do. So that's really what a video card is, or a GPU or a graphics card. RAM stands for Random Access Memory. What is RAM? Why is it important? Well, RAM is basically very fast. So when you load an application, when you load a game or whatever, what your CPU does is it basically tells your computer to load. It basically takes your stuff from your hard drive, from your SSDs, and it loads it to RAM so it can actually run quicker. That's why you may have noticed that when you open up an application once, let's just say you're opening up Microsoft Word, you open it up once and it takes a little bit longer, you close it and then you reopen it, it opens up much quicker the second time around. The reason is because part of the application has been loaded onto RAM, and RAM is actually much faster memory. But if you're wondering, well, why don't we always use RAM for everything? Well, RAM is volatile memory, which means when your computer shuts down, it loses everything that's here, unlike your SSDs or your hard drive. That actually keeps the memory, which is called non-volatile memory. This is called volatile memory. Now, RAM is also more expensive because it's faster. Generally, when something is faster, it costs more in terms of memory. Okay, so RAM, when you're running Windows, it typically idles around 3 to 4 gigs. So I got 32 gigs total, so I got 4 8-gig sticks, totaling 32 gigs. Do you need that? Well, again, it depends on your use case. I think it's really good to have. I think you should have at least 16 gigabytes. I think 16 is a really good number for RAM. But because I do a lot of video editing, it actually uses up a lot of RAM, so I got the 32 gig. When you're getting RAM, you have to look at two numbers. First, the clock speed. This one is 3600 megahertz. And second is your CAS latency, or there's a number that starts with CL, or sometimes it says C and a number. So this one has a CAS latency of 14, and you see it in the model number. where it ends with 3600 C14, so 3600 is the megahertz, and 14 is the latency. So what is this latency and why is it important? Well, latency is when your CPU requests something, it takes that many clock cycles for it to return with what your CPU wanted. So the lower the number of cast latency, the faster the response time. And the higher the clock speed, the faster the response time. Alright, my favorite part, the SSD and NVMe. The reason why I say that is because, well, what's a solid state drive? Well, this is the piece that when you're installing Windows on this, when you're installing games, applications and stuff, it goes on this drive, assuming you're intending it to go here. But basically this is non-volatile memory, which means when you turn off the computer, it doesn't forget. It remembers everything you put unless you explicitly erase it, which is very different from RAM, which again is volatile. Okay, I really highly recommend getting NVMe SSDs. The reason for that is that they are very, very fast. This one specifically, the Samsung SSD 980 Pro, is designed to have a read speed of 7,000 megabytes per second and have a write speed of up to 5,000 megabytes per second, which is insane. And the reason why I say that is insane is because this is way faster than even solid state drives that hook up with SATA. Those typically have read and write speeds of around 500 megabytes, which are still a lot faster than the spinning hard drives. But what this does is, assuming you install Windows on this, your operating system I should say, and if you're installing games on this, installing applications and stuff on this, this will make your computer fast. This really, it won't slow down your computer. That's what I really should say. Because if you get one of those spinning hard drives, even though they're, you know, a lot less expensive and you get more space with them, they're not as fast. And that pretty much becomes your bottleneck, which, you know, if you're getting really good parts and stuff, then I highly recommend getting an NVMe SSD, because you're not, pretty much it's not slowed down by the bus interface, because that's really fast. There's no moving parts on this, which makes it fast. That's why it's called a solid state. And it's just overall, your computer will load faster, your applications will load faster, like just all around your computer loading experience will be much more pleasant if you get an NVMe. Now, the reason why I got two, you don't necessarily need to get two, but the reason why I got two is because I do video editing. I put my 4K files when I'm working on them here, and then I also render here and stuff. So when you put them on a fast drive, usually Premiere Pro doesn't lag as much, or doesn't lag at all. I hope it doesn't lag with this computer, at least. But yeah, very important to get a fast drive. And this is my power supply. This is a 1200 watt power supply that's fully modular. Did I need a 1200? No. The only reason I'm using this is because I actually bought this a few years back. So I'm going to use this because this thing is awesome. And this thing is platinum rated, which is also awesome. So what makes this fully modular is that the cables are not connected. So you only hook up the cables that you need. So you would hook up the cables that you need and none that you don't. Whereas with the regular power supply, all the cables are connected. So if you don't want to use it, that's fine. You could zip tie it, put it somewhere else. But this one, it's cool because if you don't want to use it, well, then you don't need to connect it. Now, what's the advantage of getting a platinum rated or a gold rated or bronze rated power supply? Well, the thing is that when you have a power supply, if you get a regular power supply, let's just say, for instance, my computer needed 500 watts of power, as an example. Well, if you get a regular power supply, because it's not rated, it could technically even draw 800 watts of power from the wall to give you 500 watts of power to your computer. Whereas with the platinum rated one, I forget the efficiency of this, but basically this is going to take a lot less power. It will still take more than 500 watts to actually give you 500 watts, because there's still going to be some power loss even with the platinum rated. But platinum rated is going to give you the most efficient, so it's going to take the least amount of power and deliver to this. Now, this is good because I mean, it's not going to save you. I mean, you're paying more for a platinum rated one. It will save you money down the road. I don't know how long you have to use this for it to make up the cost. Because if it's taking less power to actually give you the power that you need, that's actually better than taking more power than to do that. But yeah, I just like it because it's efficient. I also like this one because it has the Corsair link cable, which you can hook up to your computer, and this one will actually show you how much power it's taking. So it's actually pretty awesome. And for this computer, I would say an 850 watt should suffice. It should be fine. Anything 850 and above should be fine for this setup. And the only reason is because this video card, the 3090, takes a lot of power. And I also had some fans lying around. I'm gonna hook these up, see if they're quiet. If they're not quiet, I'll probably get some Noctua fans because those are amazing, amazing fans. All right, let's get to the build. All right, so I took out the motherboard. Now, before we begin, I quickly want to remind you guys that don't put this on carpet. Don't put this on anything that could cause static electricity. Otherwise, it might damage the board and other parts. Now, if you have the equipment to be able to ground yourself, you know, with the wrist straps and stuff that connects to something, I don't have that, so I'm going to do the next best thing, which is put it on a non-conductive table, you know, like wood or plastic, something like that, where it's not going to basically cause any static electricity or reduce it as much as possible. So anyways, here we go. Now, before I put the motherboard in the case, I quickly want to attach these mounting brackets to the back plate. So there's a back plate behind this motherboard. Now, if I put the case flat down and I remove these screws, the back plate's gonna fall. So I would have to do it with the case standing up, or I could just do it right now. So that's what I'm going to do. So I'm gonna take a P2 Phillips screwdriver. I'm gonna try to be very careful with this motherboard. Right now it's essentially sitting on the back plate, and we're gonna remove these. And it's always a good idea to touch the motherboard as little as possible. Okay, so this is the back plate. You see these four little pieces. If I lift the motherboard, it'll come off, and that's what would happen if I were to basically, if the case was you know, flat down, then this part would fall and then it would become really hard. So we're gonna put these spacers that comes with my heatsink, my CPU cooler, and then, you know, depending on the heatsink that you get, it's gonna ask you to put it a certain way. So I'm gonna put these like that. You obviously want to be very careful with this, and I'm gonna use the provided screws with my CPU cooler. So screw this in. Okay, you don't want to go super tight, but you want to make it a little snug. So we have the case lying flat down. We have an ATX motherboard. If you had a different size, look for the other letters. We're looking for A, and it looks like pretty much all the A's are covered with these little screw holders, which the motherboard's going to sit on, except for this one, which we don't need. So we should be good to go to put the motherboard in. So do this very carefully. Don't need to rush or anything like that. You want to make sure it sits properly. So I'm going to check everything. Okay, so I'm using a P1 size screwdriver, Phillips. Now we're going to install the NVMe SSDs. So what we need to do is, it's actually going to go underneath this heatsink and this heatsink. So we have to remove this, this, and this, and then install it below it. So I'm going to start by taking this out. And I'm using a P1 size Phillips screwdriver. So the X570s usually have fans. Guess it's a common feature. Since we're going to install two, I'm going to remove this one and this one. Since we got a size of 2280, which are the dimensions, essentially the width and length, we're going to put the little screw holder here, because you could see the little 2280 here. I don't know if you could see that in the camera, but it says 2280 here. So it supports multiple sizes. You can get a 2242, 2260, 2280, and 22110. So 2280 is a very common size. So the motherboard comes with this little screw which lets you put another screw in, and we're gonna put this where it says 2280 because that's where we want the SSD to sit. So I'm just gonna hand tighten that, doesn't need to be crazy. And I will do the same thing for the other one, which that says 2280. I don't know if you can see that in the camera, but that's the size of 2280. So that's 2242, 2260, 2280, and 22110. So this one, the NVMe, you kind of put this at an angle, maybe 30 degrees or so, and then you just gently push it in. Do not force it in, don't go crazy or anything like that. And it's in, and now all we have to do, probably helps to have a magnetic tip screwdriver. So it doesn't need to be too tight, and that's it. That's all you have to do. So the other one goes here. Again, 30-degree angle. Slowly, gently, very gently push it in. Do not force it in. There it is. So they're both in. Do not remove these stickers. If you're thinking about removing the stickers, do not remove them. But you will need to remove this part of the sticker. So it says remove everywhere. Well, holding it upside down, it says remove everywhere on this. So what we're going to do is I'm going to remove this, just this plastic piece. I'm going to leave the other adhesive on there. So this is kind of like a, really just an adhesive, I guess. So then gently gonna put this back. Gonna do the same for the other side where it says remove. So we're just gonna remove this. Doesn't have to be crazy tight, just a little bit and should be good. Alright, time to install the RAM. Now for the RAM, because I got 4 sticks, I'm going to use all 4 of these. If you didn't get 4, if you got 2 or if you got 1, open up your motherboard manual, which it should tell you where to install it. So if you got 1, you would basically put it here. If you got 2, you would put 1 here and 1 here. And if you got 4, obviously you're going to use all 4. Now they do recommend to always get the same RAM to get with the same cast latency, which is something I talked about earlier, the CL rating or the C rating. So usually it's always a good idea to get the same exact RAM with the same exact speed, same exact everything. That's what I recommend. Alright, so now we're going to install the RAM. This is DDR4 obviously, so we're going to open these up, all 4. And because mine are all the same, it doesn't really matter. And when you open up the RAM, it has this little sticker on this thing. I don't know. I recommend removing that. It's not always obvious. It's kind of hard to see. Now again, if I only had 1, I would install it here. And you want to look where this notch is, because you know this part's longer than this part. So you know once that's open, we're gonna go like this, line it up, insert it through here and here, put it in evenly as we can, and then push it down from both sides, which will snap it into place. If I got 2, I would have to install 1 here, but because I got 4, I'm just going to put it right next to it just to make the other installs easier. So make sure these are in, and that's it. Time for the CPU. Now, for the CPU, you basically just have to take this metal piece, just move it a little to the side and lift it up, which is going to move this part a little bit. I don't know if you could see that, but you lift it all the way up. And then there's a little triangle arrow on this side, which is only on one of the sides, happens to be on this side. You want to line that up with the CPUs. Do you see the little triangle here? That's what you want to line it up with. You also see that here as well with the triangle. Now, when you're holding the CPU, try not to touch this part. And when you're placing it down, do not force it in. It should just sit and it should be effortless. Do not force it down. So it already sat in. And then once it goes in, then you push this down and that's it. So the CPU is in now. Alright, time to apply the thermal paste. I turned off one of the lights so you'd see less of a reflection on the CPU. Normally you would need to wipe the CPU with an alcohol wipe, but because this thing is brand new, I don't need to do that. Now we're just going to put one little kind of dot in the center. And that should be good enough. Let me zoom in. You guys could see that. That's basically what it looks like. Okay, for the CPU cooler, you would also need to clean this, but this is brand new as well, so we're good to go here. Now, it's important for the fan placement. It looks like this fan is going to blow this way. Now, because these fans are blowing this direction, I want to put this to blow in the same direction. I'm also going to put a fan here later on. So you want kind of one directional airflow. That way it will be optimal for cooling. And I will take this part off and we will put the CPU on. Now this heatsink came with its own special screwdriver, so I'm going to use that. And we're just going to tighten this. And you want to tighten it as evenly as possible, which I should have removed the fan. Let me do that now. So I'm kind of tying it evenly so it's not like pushing the thermal paste to one side. At least I'm trying to do it as evenly as possible. Alright, time to put the fan back on. Again, make sure that airflow is going this way. There's a little arrow here. I don't know if you guys can see it in the camera, but it's pointing in that direction. And because we're going to hook up the fan to this side, I'm going to take this wire and put it there. I will line this up. Should be good to go. Good to go. So the cool thing about this heatsink is that if I don't like this color for the fan, I can actually easily change it. I can also add another fan here. My video card is actually huge, and this part of it, even though it's fairly flush, will not allow my video card to go all the way in. So I actually have to remove this part, but it's very simple to remove. There's a screw on the other side. It's one of these types of screws. You unscrew it and just slide it up and it comes right out. So super easy to remove. And now my video card will fit. Before I put my video card in, I'll take this part out as well. And once you put the video card in, you can't take out the SSD and NVMe's without taking the video card back out. So just as a heads up. So video card is going to slide right in, and I should mention that you actually have to open this part up and then put the video card in. So make sure these PCI Express bus goes directly into that. Okay, so once you hear the click, basically this little piece right here comes back in, and if you want to remove your video card, you actually have to push this down again and then remove it. Otherwise, it's not going to come out. So again, we're going to pop it in, that's going to come back in, and now we're going to put these screws in, which is going to take maybe a few minutes because I have to kind of like push this in while screwing that in. It's much easier if there are two people. Alright, video card's in, everything's good. Now we need to make all the connections, the power connections, the CPU fans, these fans and stuff, they all need to be connected. Time to connect the power supply. So I have all the cables that I need connected. So I got the 24-pin ATX, which goes to the motherboard. I got the 8-pin for the CPU, which also goes to the motherboard. My video card requires 3 8-pin connections, so I have these PCI Express ones. Now I have a few options for that. So option 1 is I could basically use one wire, it's just one single wire that's hooked up here, and use 2 of these 8 pins, which I believe each one can handle 150 watts of power, so this cable total can take 300 watts. And then I would use the third 8 pin from a new wire, and that should give me the 3 8 pins, and then this fourth one I would basically just zip tie or something and not use. What I can also do is add another one if I wanted to, and basically just use one 8-pin from here, zip tie the second one 8-pin from here, zip tie this one, and then one more 8-pin from here that's coming directly from this. But I don't need to do that, I'm just going to try it this way, it should work. This is the Corsair Link digital cable. This one, when you hook up to the motherboard, when you install the Corsair software, it actually shows you how much power it's taking from the wall and how much power each device is taking. So it's kind of cool, so I'm going to use that. If I had any SATA devices, like a hard drive, a solid state drive, a Blu-ray drive, then I would need SATA power as well. In that case, I would get one of these cables, hook it up here, and then this would give me SATA. So several, it looks like gives me 4 SATA power if I need it. There is this SATA connector here, so I might actually just hook this up just to have it in case if I add it later. So in order to slide this in, I actually have to remove this hard drive bay because my power supply is fairly large. If you're wondering, the fan is going to face down because that's where the airflow is. So I'm doing this on purpose. It's not that it's upside down. Actually, from the other side, it shows this sign correctly. But you want the fan to be pointing down, regardless of how this looks. And we will screw it in from the back. Okay, so we lined up the screws. So there's one here, one here, one here, one there. There it is. Alright, now here comes the fun part. Wiring up the front panel I/O, the power supply and stuff. Pretty much anything that needs to connect to the motherboard. And I probably should have installed the video card after I connected this stuff, but I feel like there's enough of an opening to get through. Now, this is going to be the most tedious one to connect. Everything else is pretty much a straight single plug-in, where it's just like one piece and that plugs in. Whereas this one requires a tad more effort in this narrow spot. Not a big deal, but basically we have our reset switch, we have our power switch, and we have our power LEDs. So the reset is for restarting the computer, the power is to turn on the computer and turn it off. And the power LEDs actually don't even need to be connected. They're the light indicator that, you know, when you turn on the computer, the light goes on and stuff. So if you don't want that light on, you just don't connect these. So they typically go here for the front panel I/O. The way you know which pin it is open up the motherboard manual and you know, depending on the motherboard you have. For this motherboard, we have the power LEDs go here, these top left two, and really the top is really the speaker, so it's below that. Really it's the middle left two. And then we have the power button, which is to the right of that, and we have the reset switch. This is the hard drive LED, which we don't even have a cable for that, nor do we need it, because this thing, the SSDs are so fast. You're not going to hear that spinning thing, loading kind of thing. Okay, so basically, I'm just going to connect these and we will go from there. So let me zoom in so you guys could see what I'm doing. Alright, now that we're zoomed in, so the reset switch is going to go right here, all the way on the bottom to these pins. So the left two have to be open because those are the hard drive LEDs. The power switch is going to go right above that. Okay, and then we have the power LEDs. So let's hook these up. Probably should have started with these. There it is. Okay. Alright, next we have our USB 3.2 Gen 1, and this one's actually much easier to put in, and you know, don't force it in, but this thing can't go in the wrong way. So you see the little thing that's kind of popping up on the top, so, and you see that this hole is blocked. So basically I'm going to flip this upside down, put some light on this, and just pop that in, and there it is. So next are the USB 2.0. So this one's for the RGB controller, and you could see one of these pins are blocked out, one of the holes are blocked out. That's intentional, and when I zoom in, you could pretty much see that one of them is open. So I'm referring to the two to the right. So I will hook this up to the first one, and you could see the pin on the right most bottom is missing, so I am going to flip this over. So they're both in. And finally we have the audio, and you know, this one is missing this piece, so you could see that that pin is missing right there. And so I'm just gonna flip this upside down like this and connect it. Okay, so that concludes the bottom. So we have our audio connected, our USB 2.0s, our USB 3.2 Gen 1, and we have our power switch, reset switch, and power LED. Alright, getting to the top part, we have our USB 3.2 Gen 2, which goes right here. So simple connection in, and that was easy. So very, very simple. We have our motherboard power, which you actually can't put this in the wrong way because of the shape of this stuff, and this is the clip, and this clip goes on this side, so you know, put it this way and just push it in. Do not force it in, and you should hear the clip, which I did. And again, I'll zip tie it in the back, make it all pretty and stuff. And here's the Ninja one for the CPU. So this motherboard actually has an 8-pin and a 4-pin, but if you read the instructions, it says you only really need the 8-pin. You could do the 8-pin and the 4-pin, but you need at least the 8-pin. So I'm just going to do the 8-pin, and it's the same thing where the clip is on this side, so I'm just gonna flip this over. There we go, clipped in. And now for the video card, we need 3 8-pins. So again, I could use 3 different cables, or I could just use one cable for both of them, which I will do that. So these things can be 6-pin or 8-pin. Obviously I need to connect these and push it in this way, so it could actually be an 8-pin. So I will connect this in like this, clipped in. We need to hook up our CPU fan. CPU fan is the top left, so that's what we need to hook it up to. That's actually super important. And finally, I'm going to hook up these 3 fans. So this one I'm going to hook up to CPU optional, which is right below the CPU fan. So I'm going to line this up, and the 2 from the bottom, I'm going to hook up one to the M.2 fan, the other one to channel fan 2. The reason why is when I look in the manual, I don't want to hook it up to AIO pump or W pump. Those run at full speed, especially W pump plus has more power. So I'm just going to hook it up to a Q fan controlled one. Later on, I may get an adapter that goes from SATA power to fan and try that out and just see how that works. So, but for now, I will hook it up to M.2 fan and channel fan 2. And channel fan 1, I'm just gonna save because I'm gonna put, it's right here, and I'm gonna put a fan here, so I'm gonna hook up channel fan 1 to that. And this is the SATA power that goes to the RGB controller. So if you want your fans to have colors, the 3 fans in the front, or if you want to add more fans to that, then you need to hook this up to SATA power, which I will do here. And that's pretty much it. Now I'm going to zip tie everything, clean it up, and we'll go turn it on. Alright, we're going to power it on. And we're going to go to BIOS, so we're going to hit the delete key to go to BIOS. Once we're in BIOS, the first time we go in, it's actually going to be in easy mode. Make sure by default this thing is going to be disabled. I don't know why it's not letting me click disabled. Right. Okay, so when it's on disabled, you could see that my RAM is actually not going to run at its frequency, at its advertised frequency. So we're going to enable this by selecting profile 1, and then you're going to see that yes, it's at 3600 megahertz basically, and this is the cast latency for that. So that's really the only thing that you need to change off initially. And then if you go to advanced mode on boot, make sure you plug in your hard drive, make sure this is selected. You can also select boot override. You don't actually have to select this here, but it should be the only option because there's nothing installed on this. So, or you could click on this directly, either way, and it would basically load it to get Windows installed. So now it's going to load Windows, and I'm just going to install it on one of my SSD NVMe's. So, you know, pick your language and stuff. I'm gonna pick this, the default ones, that's what I want. I'm gonna click install. And it's asking me for my product key. I don't know if the camera could see that. Let me see if I could zoom in. There it is. Okay. So it's asking me for this. You could enter it now. You could also enter it later. So that's also fine. So I'm going to click I don't have a product key because I'm going to enter it later. So when you do this, you actually have to pick the Windows that you're going to install for the product key that you're going to use. So I'm going to put Windows 10 Pro. So I'm going to select Windows 10 Pro over here. And then I'm going to click next. And then I'm going to, you know, accept, you know, obviously if you want to read through this, read through it and accept it if you need to or whatever. I'm going to accept it. I'm going to click custom. Now, because both of my drives are basically unused, I have, you know, drive 0 is unallocated, drive 1 is unallocated. So I'm just going to pick one of them and I'm just going to click next. If there were other ones, you know, if it was partition, I would basically, you know, delete those partitions and make it into one. Obviously, if it was backed up. So make sure all your stuff is backed up. Because these are 2 brand new drives, I'm just going to select drive 0 and I'm going to click next and just wait basically. So at this point, I'm not going to go into BIOS. I'm not going to touch anything. It's going to automatically boot up and pick the correct stuff. Alright, so I'm going to pick the United States because I'm here, and US, and no, not right now. Alright, so I hooked it up to the other LAN port, so now I'm just going to click next. Alright, so I'm going to click setup for personal use. At this screen, you have a few options. You can log in with your Microsoft account, meaning your Outlook email address, your Hotmail email address, your MSN email address, anything that's basically Microsoft. Or you can make an offline account if you don't want to use your email address and you just kind of want to log in just with a generic one. So you can do that. I'm going to use my email address so it could just make life easier for me. So I'm going to log in with that. And I'm going to improve this on my phone. Okay, it's approved. So I will create a PIN. So these, I turn off most of these. So online speech recognition, location, I guess I could leave, diagnostic, tailored experience. That one you could leave on or off. This pretty much personalizes the ads for you. I guess I could leave that on. It doesn't really matter. Advertising ID, inking and typing, so no thanks. And I'm just gonna leave my device location on. I don't think it really matters for this. So I'll basically leave these on, and I'll leave on tailored experience. So accept. Yeah, I'm just gonna do skip on this, just because I don't really care about that. No, I'm gonna skip that as well. You could basically say no, I don't care about that, only save files to the PC, or you could just click next. I'll do next just because I want my OneDrive access, and no thanks, and not now. So Cortana is basically the Windows assistant, and now it's going to do everything else for me. So don't turn off your PC, don't touch anything, just let it do its thing. And there it is. It's pretty much installed. Alright, so I'm going to turn on my computer and we're going to see how fast this is. And it's especially going to be fast because of the NVMe solid state drive. I mean, all the other parts really help, but it's especially going to be fast because really the solid state drive is not slowing down. So it already turned on. And here's the beauty with solid state drives. My computer is fully usable now. I don't have to wait. So I already opened up PowerPoint. This is already open. I opened up Excel. This is already usable. Word is usable. I'm opening up Adobe Premiere Pro, Photoshop, Illustrator, and After Effects. So all of these are being opened up pretty much almost at the same time as humanly as possible. You saw that I clicked through this. But this is the beauty you get with solid state drives. And even if you don't even if you have like a normal CPU, getting a solid state drive, because if you have a spinning hard drive, a lot of the other parts are really just waiting around for your spinning hard drive to load and give it data and stuff to let it access the applications and load it onto RAM. All that stuff takes a lot longer when you have spinning parts. But when you have a solid state drive, this is the beauty, that you could basically turn this on and it's fully usable. And granted, yes, this CPU is faster, this RAM's really good, everything's good here, so this is going to be even faster than that. But even with my last computer and like my laptops and that other stuff, it still loads fairly quickly, and once Windows is open, once we get to this desktop screen, the computer is usable. I don't need to wait another minute or 2 minutes or 5 minutes or whatever, which I used to have that issue many years ago when I would turn on the computer. Until I went to a solid state drive, I was like, oh wow, that was literally the biggest difference that I've seen. And one other thing that I wanted to show you guys was... Okay, so now that we actually had 2 drives, you see that the second one's not showing up. So this is what you do. Click on Windows, type in disk, which will take us to disk management, so press enter on that. And you could see that we have the second one, it's unallocated space, which is our disk 1. So if you actually right click on here, you click on new simple volume, you click next, you're going to pick the biggest possible size. You could partition it as well if you want, and just click on, selecting the D drive, which is fine. You want to call your volume label whatever you want to call it. I'm just going to call it local disk, and then I'm going to tick the perform a quick format, which is going to be very fast. And once you do that, it shows up. like no problem. This method should work with any hard drive or solid state drive or anything like that. So now when we open up Windows Explorer, you can see that they're both here. If you click on it, it's ready to go. If you guys enjoyed this video, please like and subscribe. Thank you guys for watching. If you guys have any questions or comments, please leave it in the comment sections below.